Okay, so if you're a little sketchy on where stuff is, just ask. Like, there's nothing wrong with asking what the base function is, and then just tell me all the stuff about it. What? Alright, we're still going. Semi-random thought as you're all doing this, and just again express my appreciation for how most of you are very organized, because going through your stuff after a quiz compared to some of the other classes, smooth. Algebra 1, algebra half, oof. You'd think it wouldn't be that hard to just, write stuff in a notebook and have a packet of notes and maybe throw it in the folder so they're together. But no, it's like a pile of random papers, and this packet and that packet are like stapled together, but the pages are out of order, and there's something torn off of there, and in the middle of their math book there's a biology lesson, and
No.
All right, good talk.
That's
There are dumb questions, but if it's about the math, it's probably not. If you ask a mathematical question in this room, it is not a dumb question.
Something really hard on us. I can't remember.
Well, it's open notes, open everything. Go back and flip through the stuff we did yesterday and see if something jogs in memory. I think that's why it's open notes. Sometimes just seeing the thing that you did while we were talking about that jogs the memory because there are connections in the brain. That's why if I want to remember a really specific conversation with someone and I know that I never will, I code it with a really dumb phrase. Said, I will forget this conversation in another 10 minutes. So when you come in on Monday, I want you to say the words, fuzzy pink bunnies beating up clowns. I'm like, what? Say it. Triggers the conversation. You can keyword things like that. You can do the same thing with your notes. Why do you think I say all this stupid stuff? It's not just because I have no filter. When you tell a bunch of kids in Algebra Half, Algebra 1, what happens when this is smashed up on something else? It's like rabbits and hormonal teenagers. They're multiplying. You say that, they're going to remember it. That's what Mr. Larson said to me in like 8th grade. It was great. He also liked to call improper fractions Dolly Parton fractions because they were top heavy. Mr. Larson was a guy. That you know of. This was Northeast North Dakota. His family was all that stomping grounds. Northeast North Dakota. There's a lot of crossover between the Minnesota land. No, that's Walsh County.
I grew up here.
Okay.
And my mom lived in that.
Okay. Oh, so you weren't too far from Valley Fair and the Ren Fair.
No. No, I lived in Edina, but this one that far.
I missed the Ren Fair. That was. Oh. South Dakota, I don't know of one. There might be a traveling one that shows up every now and then, but. Okay. We're all good? All right. So let's actually start at the end. What's the parent function? 1/2 to the x. Even though I can write, like, 1/2 is 2 to the negative first. So then I could bring this upstairs and say that's 2 to the negative first, the negative 1 distributes into here, now I have 2 to the negative 1 by x minus 1. Well, I could do that to graph it, but whatever the base is, that's your parent function. Just, what does that look like? If that's all I had. Just the general shape. Okay, starts up at positive infinity, comes down, hits that 0, 1, and then curls along the asymptote using powers of 2. So that's what it's going to start as, but then I'm going to do all this stuff to it. We're going to vertical reflection or reflection in the x-axis, a vertical stretch, or you could just say dilation, stretch, there we go, by 2, a horizontal translation, right 1, and a vertical translation, up 1. So let's get the graph then. Green. So the vertical asymptote that was here gets shifted up 1. Or words. Words are hard. Do what I do, not what I say. I'm adulting wrong. Hold on. So, okay, I do that. Then normally, I would be just 1 above that asymptote, because anything to the 0 power is 1. It's going to get shifted, right 1. It's also going to be reflected, so we're actually headed down below that axis. And it's going to be twice as far. So, there you go. From there, you move onward with your powers of 2 in this direction. Okay? But you have to remember that along the way, you're going to be doubling them. So, 2 to the first, 2 to the 0 is 1, double it. 2 to the first is 2, double it. 2 to the second is 4, double it. 2 to the third is 8, double it. Okay, we're already off-road. 2 to the negative first is 1/2, double it. And then half, and then a quarter, and then. So it really is just those powers of 2, it just kind of got monkeyed with. Ta-da! I run through all that to show you that if you have the transformations, you don't have to graph by table, but that's a lot of transformations too. That's like trying to juggle 7 things at once, and 2 of them are on fire. So, like, I'm not coordinated enough to just confidently throw this in the air and catch it. So, I understand if you just want to do that by table. Once I got that, I'd say we're in business. Domain. Range. Okay. X and Y intercepts. We actually have them this time. Asymptotes. No vertical asymptote, but I do have intervals of increase and decrease. Approaches negative infinity is negative infinity. Limit as x approaches infinity will hit that asymptote. That's a lot of stuff. How do we turn that into 5 points?
Domain and range 1.
Domain and range. Intercepts. Asymptotes and behavior. Or sorry, asymptotes and intervals. There we go. Our transformations 1 and a decent graph. Okay.
Yeah, it took up a lot.
Have at it.
No, I
Oh. It's like, I'm going to throw a punch. Do it. Oh, do we have any questions on it? No? Okay. I remember that showing up in my quote book. Hey, Kevin, it's Throat Punch Thursday. Like,
That's so funny.
Foot and Face Friday?
Yes.
Like roundhouse kick? Okay. I didn't get any questions.
turned the page in my notes, and I was like, oh.
Okay.
Because I couldn't figure out the continuous.
Um.
I tried to ignore that, and then I forgot about that.
Yep.
It was very easy.
Okay. Another thing. These should have been fairly simple because it's all review. Like the graph analysis stuff, we've been doing that for months now. The only difference was a little bit of formula stuff, and you did that all the way back in Algebra 1. And you did it again last year in Algebra 2. I don't know that I asked this class, but I kind of talked with my Algebra 2 about homework. Excluding last night, are we doing okay on time? Is it at that, now pre-calc I would say probably more around the 20-minute mark, or is it past that on a regular basis? Would I think that how things are going on our quizzes are pretty indicative of we're getting enough practice in class. Like that's my goal. I would rather that we did that. In fact, if we were doing well enough, ideally I would say no assignments at all. I don't know that we're there because sometimes we want to see that application. There's also a big difference between following along and doing it on your own. I can watch someone play a guitar all I want. Until I actually start doing it, I'm not going to learn. Okay? Throws shade at every person who ever played Guitar Hero and thought they could join a band. So.
I'll teach you how to play guitar.
I'm not surprised. So the last thing that we had was continuous interest. It was that same thing, except now principal E rate 0.06 times 20, right? I think that's where we left off. We hadn't been doing the got it ones yet. Okay, but if I remember right, now some of you are already packing up, we got through there and was like, oh, hey, look, different button, different formula. What was the thing we had to write down? Continuously. Like, if I said, use this model, this data, blah, 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 to figure out, I don't know, the average number of people who are going to have a heart attack on Halloween. Okay? If it's specifically on Halloween, then I could use that's every year, right? But if I said, how many people does this happen, over the last 20 years? Well, it's happening every day. So I don't want to do like compounded quarterly. Like, hold on, Grandma. Like, you got to wait until the 38th first so you can, yeah. Like, things that happen in the real world context are typically going to be continuous model. Just so we're clear. So don't even worry about those ones. Instead, was I going to do the thing? Yeah, I was going to do the thing. Instead of that, let's have a little real talk. Instead of these ones. Y'all got phones? A couple of you got computers out?
No.
Let's say, best case scenario for a 4-year university experience in terms of finances, you go to your hometown because you get that in-state tuition. Okay? You all know that if you go in-state, you get resident tuition, right? Okay. So, real conversation time. If you go in-state, you get resident tuition, which is half of the out-of-state tuition. So, for example, if you want to go to college and you go in South Dakota, maybe it'll be, I don't know, $40,000 for 4 years. versus if you decided you're going to go to Maine, it'll be 80 some thousand, assuming their tuitions were identical. It's just whether you're a resident or not. They do that because they're trying to keep people in state. There are other states that will have what is called reciprocity. Reciprocity, reciprocal, goes with, together. You scratch my back, I'm going to scratch yours. South Dakota has reciprocity with most North Dakota, Montana, Wyoming, I think Iowa, some Minnesota. Minnesota's got a lot of bureaucracy. Um, like, we have reciprocity with a lot of the neighboring states, and that's usually what happens. Because the idea is if you don't want to go to one of the schools in the state, then at least if you go to a neighboring school, odds are you'll still stay in the region. They're trying to keep productive workers in the same region.
Yeah. They're building a ramen noodle factory, bro.
Where'd that come from?
Because they were talking about keeping people in state.
Oh, yeah. Yeah, they're going to make a ramen factory. But, yeah.
Wow.
They're going to have noodles! So, bring them back here. I would like someone to grab a phone, Google, whatever. Let's just, whether you want to or not, tell me what is the annual tuition at BH? Say that again, Grace.
This is just tuition and fees. 8,763 per year. That's just tuition and fees, not the yearly cost. Oh.
That is tuition and fees. That means you are going to live at home, and all of your expenses are paid for at home, whether.
It's room and meal plan that drive it up to 17,000.
Yep, if you want to live, because no. The idea is if you're living at home, when all of your utilities, your food, your all that stuff is somehow taken care of. Whether you are just living at home with your family or whether you have a job and you are providing for yourself, you are not getting it through the university. Best case scenario, hometown college, in-state tuition, not living on campus, so you're not having to pay for your dorm, you're not having to pay for room and board. Like, this is just, I go to school. Okay. It depends on the school, depends on. Usually what BH will do is they'll say either you're staying at home with your folks, local, or you're in the dorm freshman year. I would say, y'all, do it. Do the dorm thing at least your freshman year because you got to have that experience. Oh no, we had like hallway baseball and sledding down the stairs out the fire doors. I had random people in my room playing video games while I was asleep. Like, yeah, have fun.
That's not scary at all.
It's not scary when you're a large cishet white dude.
Yeah, but I'm a small.
That is a different experience, yes. But let's say you're going to do that and you're going to pay your loans back later. A typical, let's say you didn't qualify for FAFSA. You didn't get the federal subsidized loans. Maybe mom and dad make too much money. That happened to me. I moved out the night of graduation. I'm on my own. Screw you guys. I'm out of here. Amazing. Freedom! But at the same time, I also didn't qualify for a bunch of loans because it's based off of your parents' taxes. So I had to go private loans. Private loans, if you're good, maybe you'll get like a 5% rate. Maybe something as low as 2%. We'll say that you're in a really good situation, and we're going to say 2.5% interest. Now, what typically happens is they defer the loans until you graduate because your job is to be in school. After you graduate, they usually give you like a year leniency. It's called a grace period, and then after that, now you have to start paying back your loans. They typically want you to do it within a 5 to 10 year period. I'm going to just wing it and say in the middle 6 years. If your interest is compounded quarterly, monthly, annually, or continuously, I would like you to find how much will 4 years cost. Mm-hmm.
So you said that it was like a real life situation or something that you do with the RT, right? Only if it's continuous.
But I'm explicitly saying do those. Yes.
If you don't say that though in a real life situation, you say
Real life situation like related to physical environment in terms of finances, they will tell you when to compound it.
What is their funds? Under online banking, right?
What?
4 years and 6 years.
No, 4 years of that tuition.
Okay.
You're going to pay the loan over 6 years. So basically 4 years times tuition is your principal. Okay. Here, together. That's your principal. I'm just trying to throw some numbers at you and maybe shake you a little bit and say, hey, you should actually apply for every scholarship you can next year. Or in 2 years. The same thing happens in my algebra half. I have 1 sophomore in there. 1 sophomore and 27 freshmen.
Sounds like me and my computer apps class.
A kid who had a really bad experience last year.
Your N is years. Is it 4 years or 6 years?
4 years of that tuition is your principal. You're going to do the loan for 6 years.
So 6 equals 2.
So basically, how much are you going to end up paying by the time you're done paying the loan? This is also a very simplistic version. Like, it gets more complicated than that. Semi is twice a year. Because that's your principal, yes. It's a lot. What was that? 8763. So raw amount 35,052. Rate was 6%, right? Oh no, 2.5. The 6 was the years. Okay. So 0.025. There we go. Over, if we're going to do this quarterly, or to the 4 times, and we're doing this for 6 years. 40 grand for college. Give you an idea how much things have changed. You know what, let's get the rest of them on here first. I can highlight that and go back and just change that over to, what do we say, monthly? A little more. Versus do the same thing we said annually. Annually is actually fun because it's 1 time per year. Annually, how many times does it happen per year? And then part 35,052 e to the rate 0.025 times 6. Okay, so we get our different amounts. Please write them rounded off to the nearest hundredth because we're talking about money. It's one of the few times that I'll say that. Unless you're at the gas pump. Then it's like $3.49 and 9/10 for a gallon of gas. I'm hop up on my socialist box here. The people who make policy, who decide, like the Board of Regents for every state Department of Education, the people in Congress and the Senate who decide things about your life, you got to remember that when they went to college, they could get a part-time job at the rec center in the summer, and that paid for college. They could go work 30 hours a week at the golf course during the summer, and it paid for college. Those are the same people who say, I worked my way through college. Why can't you? That's why.
At Nebraska Lincoln, that's how much it is for one semester.
And this is the best case scenario. If you go out of state or you go to a private school, you're probably looking at more like 20 to 40,000 per year. Imagine if you go to a more prestigious school. That's the reason that I never went to an Ivy League, because my 35 instead of 36 on ACT meant I did not get my free ride anywhere. Because I got one question wrong and I'm still bitter about it 20 years later. That was a lot of money. I don't have that money. I moved out. I was making like $8.25 an hour at the state park, and that's when minimum wage was $5.15. I thought I was rolling in it. Dude, my who? Monday. I might. I don't know. We'll see when it is. I'm also incredibly stressed, and I might have gotten dumber because. Blame it on algebra half. No. No, I mean just life stresses. Yeah. No. After 180, the IQ tests are no longer reliable. Like, they're statistically not reliable past 180.
Because people aren't smart enough when they make it.
Literally. Also, any test, any standardized test, from your ACT all the way through IQ, all the way through ADOS, like, it doesn't matter. They're all culturally normed, so they're not reliable for all groups. There's also people who learn and assess very, very differently. I've got 2 kids right now who come in and they do their tests after school with me individually sitting in my chair, spinning circles over here, playing with fidgets while I write on the board and they just tell me what to do. Because that's what works for them, and they're getting B's on everything. These are kids who have never passed a math class in high school. Okay? Everyone learns differently. So those tests are subjective. Again, straight cishet white dude, right? Like, those tests are made for me. Plus, I like taking tests. Because I'm autistic and I like tests. I just like numbers and scribbles and playing with blocks. It's fun. Oh yeah, the ones where it's a whole bunch of like dice that are different like triangle colors and they say, here's a pattern, make it. Cisgender. You are the gender you were assigned at birth.
I am also cis.
Okay. So, continuing. Just remove. Stop. So, next up. Growth and decay. These are the ones you're probably more likely to see in a scientific environment. They should look fairly familiar, hopefully, from physical science or chemistry, where instead of using P for principal, I'm going to switch over to N sub 0. Now that's not like, you know, sub 0, where you turn the guy into a block of ice and then uppercut him to the next level. Sub 0 is... Sub 0 means the first, the beginning. Okay? This means the amount when I started. Before the first data collection, before the first year. The amount you started with. It is the principal. And you notice they are almost identical to our other formulas. They're just written in science stuff. Okay? What I want you to pay attention to, though, is R and K are specifically going to be called our growth and decay constants. Our rate of decay, our rate of growth. They got their own special name because science. Okay? I get to use those formulas to do things in the real world that don't involve money. Like, you got a population, if it continues to grow at that rate, how big is it going to be? Okay, that's an exponential model. So, I'm going to say 110 million is my initial amount. I don't have to put all the zeros on there. I just know that my answer is in millions because I'm taking 110 times whatever my exponential thing is. So 110 times a thing, and then I put the word million versus 110 with a bunch of zeros, it's still going to be 110 million. So I take that thing times 1 plus my rate, 0.0142, 2 places, to the okay. So we're going to do 2 of them. Yep. We're going to do to the 10th, and we're going to do 110 million, 1 plus 0.0142 to the 20th. I'm also going to do that in 10 and 20 years when compounded continuously. So now I'm going to switch to this n is noacht thing. N sub 0 times e to noacht. Okay. Noacht. So I'm going to have that amount is 110 million e to the rate 0.0142 10.
No, we're on a different one.
Andrew, go back a page where it has no act. It says when continuous.
Okay, got it.
Okay.
Well,
What? I got a rush.
He's laughing at the no way.
now he. Continue now. Continue now. Andy's like, it's finally coming.
I'm only laughing because it's last so right here. I think
Press the buttons. I mean, it goes along with the English predisposition towards combining way too many consonants.
What?
Sixth. I don't know. Oh, wait. The majority of our language is just bastardized hybrids of European languages, so.
It's so funny. It's like some Indian guy talking to some guy. Yo, Indian some number. He's like, okay, first letter is B. B is a boy. No, B is a Peter. Boy, no, Peter. It's like, okay, fine. Like, okay, next touch.
You should now do math.
Like etch a sketch.
You should
No.
now do math before I flick you in the forehead and stop talking.
Oh, are you supposed to plug the numbers in?
I don't even want to know when. Grab the nerf gun. Get ready to
How close are you gonna get?
Start running. Why are you studying?
You're fine.
Okay. Oh, okay.
Keep him in line.
That's so close.
Not me.
Do an execution style.
It's loaded and ready. You're good. What do we get? Ballpark. 126 and change million. But then it keeps changing based on whether I'm at 10 years or 20 years. What difference do you notice from annually to continuously? Okay.
Well, if millions is a lot.
This one has like one.
But when I compound continuously, when I find a continuous model, doesn't it have a little more oomph to it? Because it's more accurate. Okay? It is more accurate. You all know how to use formulas. You know how to press buttons. I'm not going to bother with the other one. I just wanted to run through it so you got an example. Okay? Formula plug and chug is probably a math student's favorite thing because it involves very little thought. So, using the graph, on the other hand, okay, if I can make the model, you have to be able to use it and interpret it in context. Boy, if that isn't hitting a little close to home. The table shows a number of reported cases of chicken pox. You know what changed in the 90s? We got a vaccine. So,
How lethal is chickenpox? Like, if I got it, would I be like this? Or no?
you will not be because the likelihood is you were vaccinated against it as a child.
Well, yeah, but like, if I wasn't vaccinated,
Chickenpox isn't dangerous.
That's not true.
So, it is incredibly contagious. It depends what it does to the individual person, like any other virus. The problem with it is, much like other viruses that we know about, its effects on your body last much longer than the actual infection. For example, long COVID. For example, every time you lose senses with COVID, that's nerve damage. It is literally nerve damage. When you say, dude, I can fart and not even smell it. No. The nerves in your brain and your face are now damaged.
I don't think mine's ever coming back.
Okay.
I didn't have it this time last.
Now, another thing about it is you don't know yet what the long-term effects are. For example, you talk about chickenpox. Chickenpox, you would get it as a kid. You'd have the horrible itchy rash and all the bumps. You'd go soak in calamine or something, be miserable for a week, or you can't stand goo, so you would just scratch them all off and gouge them out.
Oh, and then you'd be scarred.
Yep.
Oh.
So you would do that as a kid. And then in your 50s, 60s, 70s, you get the shingles virus. Shingles is basically where your skin entirely turns to scabs. It is the chickenpox virus come back with a boomer vengeance.
And you can't get shingles unless you've had.
Because shingles is the chickenpox virus come back to haunt you 40, 50 years later. We don't know yet what COVID's going to do. Yes, that too. So, it's almost like we should trust medical science because we have centuries of proof that it works. I got a table. Table says 1980, 190,900 cases in the U.S. versus, and those are just the reported ones, 2005, only 32,000. If it's decreasing at an exponential rate, identify the rate of decline and write the exponential model. We didn't do logs yet, did we?
No.
All right, calculator time. Okay, you got a table. Just stop talking. Stat. Edit. How do I want to write my years? Distance from 1980?
Because 19.
Doesn't say how far we're going in either direction, does it?
So we should go from the year 900.
Okay, probably not reasonable to go to the year 0 and actually put in 1980. I would say 1900 would be as far back as I would go. I would feel more confident with something a little closer.
1950.
I'd say somewhere between 1950 and 1980, somewhere with a nice number. No. All right, since y'all are doing that, I'm going to stat, edit. I'm going to put in just 80 and see what happens. I'm going to put in 105, see what happens. With them, I'm going to have 190.9. You notice that I can say in thousands. And 32.2. Do you remember how we found other models from tables with our calculator?
Yeah.
Stat, calculate. There is a whole bunch of regressions down here, and it says assume a exponential model. Exponential regression. Make sure you got your list. Make sure you store. I'm not going to run through it if you're on 83. You should know that by now. We've done it enough times. I'm going to store it into Y1, calculate, and ba-ba-da-ba-da. They give this to me as a exponential model. So I've got Y is 56,786.632 times 0.931 to the X. There's my model. If I saw that on your paper and nothing else, you're getting docked. I don't know how you got this. At the very least, say X is, I did years since 1900. That's also why my leading coefficient is so big. If I had gone years since 1980, that would change. Years since 1950, that would change. Okay, identify the rate of decline. So if everything staying the same is times 1, times 1, times 1, times 1, times 1, and I have times 0.931 times 0.931 times 0.931, what is the rate of decline? No, that's how much I'm getting every year. If I'm getting 93% of what there was last year, then my rate is going to be 0.069. Okay? 6.9% decrease every year.
Yeah.
You took 93%.
Because that says 1 plus my rate. If 1 plus my rate gets me, whoa, wrong way. This, 1 plus what makes this? Just subtract 1. Okay? So use your model to predict when the number of cases will drop below 20,000. Because we have not yet reviewed logs, I want to know when that's going to go below 20,000 before I go typing anything. Take a look at that table. Cases in thousands. So when I graph this, first of all, I need a reasonable window. We went from the year 0 was 1900. I'll just start at like 50. So that's 1950 going up through the year, I don't know, 2050. So 150. My X's now go from 1950 to 2050. My Y's, I should have an asymptote at 0, right? And my Y maximum, well, I had a data point that went up to 190,000. So I don't know, I'll go like 250,000.
But aren't you looking for less than 20? Would you have to do it?
I wouldn't. The reason I'll do that is because now if I poke my stat plots, I can turn on my actual data points. So I should see the 2 data points that I have now when I hit graph. Ta-da! How do I find out when this hits 20,000? Into Y equals. Now be careful, the table was in thousands. So I don't want to actually put 20,000, I want to put 20. Now when I graph, whoop, and how do we find that? Second, calculate my intersection. Somewhere between yellow and blue is answer. We said years since 1900. What is this? in the year 2011. If you wanted to go unit analysis on it, take 0.6895 times 300. Well, is it a leap year or not? 2011. So 0.6895 times 365. You could keep going. You could find out exactly when. But I'm cool with just saying in 2011. All right. So until we do the log thing, we're going to have to rely on calculators. Do the next one. Oh, I'm sorry. Do the next one. The next time he makes fun of social competency, shoot him. This is my version of grabbing the bucket of popcorn.
Oh. Oh. What's on my work? Rather you not. We need to test fire at the smoker. So. Wait, is it a sticky?
It's a
Or is it just like a normal one?
The ball.
Those things are actually. Oh, yeah. Those are so fun. Shoot it, yeah. You're literally gonna just straight in the nose.
Yeah. Where?
At the whiteboard.
It's going to ricochet.
Last time you shot at the whiteboard. Wait, we should see how accurate you are. Try to shoot the bank head here. The bank head, yeah.
Shoot Lars. Shoot Lars?
Yeah. I think it's actually like maximum damage.
How do you stir something?
How do you stir something? Oh.
You hit bar that you go over the function. Ooh.
Motor up.
This race is funny.
Wait.
I still don't understand how you have R. It does not make any sense.
How do you have what?
R in the last part.
Oh. Because right there. That's.
Yeah, so 1.01. Minus 1.
1 plus r equals this.
Okay, so you just like algebra it out?
Yeah. Just take 1 minus this. How far down from 100% did it go? So I can either say 1 plus r equals this. So r is a negative 0.069. Or just take 1 minus whatever this is if it's below r. Or that minus 1 if it's above r.
I do.
Okay.
It's like an absolute.
Yep. Well, no, technically r is positive or negative, but because they specifically asked for the rate of decline.
It's like a distant. Like what I mean is like.
Yep.
Maximum, what's your, what's your, I'm gonna,
Just so we're all kind of in the same ballpark. Who went with years since 1990? Because it didn't say. I'm hearing a lot of 1900, a 1950. Like, it doesn't matter, right? I should be able to. I'm going to go. I'm going to go year since 1984 because I feel like it. That hurts. So we got 6 and 16, 1.94, and 2.25. Okay, I'm going year since 1984. I got my data. I will now say window. We'll go from, what was it? That's 1984 up through at least this year. Zero again, and what was our? Oh, we're headed up from there. So 10. Okay, stat. Calculate my exponential regression using that thing. That's what I got because I used years since 1984. Mine is going to be different than yours. But if I go to Y2, and what are they asking for? 2.7 million. Oh, in which case I should probably take my window and change that to not 10. There you go. Graph. Very minimal curve, but I do see the intersection. I calculate my intersection between yellow and blue and gimme. Mine says in the year 1984 plus 28. The year we were all supposed to die, right? The third time. Which one? The one actually called just straight up 2012 that's got, what was it? Not Kevin Spacey, John Cusack in it? Yeah. Okay, what would we write for our rate? Okay. Over here, if I have y is 1.775 times 1.015 to the x, remember that that base is 1 plus r, 1 plus rate. So how far away from 1 or 100% is this thing? 0.015 or 1.5%. Now that was my model. Yours would have been probably the same rate or a similar rate. That's like...
She already shot it. She knew. She knew. She already did, so she knew that he was.
Don't shoot Lars.
I volunteered to get shot.
I already shot.
All right. So blah, blah, blah. You can press buttons the same way that you did back in Algebra 2. Yay. I'm guessing we're okay with that. On we go. Who did what? Oh, we were supposed to find something? Oh, yeah, we said, because mine was 28 years. So 28 plus 1984, 2012, that's just what everyone else had. Even if your model was different because you started with a different year base. That's what I want to show you, is that even if you... Oh, I'm talking about gum. I just heard something so old, and we were talking about 1984, and I felt bad. So,
Sorry.
oh, Right there. Logs. You saw them last year. Logarithm is the inverse of an exponential function. If I got a variable up in exponent land, we had no way to deal with that until we had the graphing calculator to do that intersection. If I don't have the graphing calculator for the intersection, good. If I don't have the graphing calculator to do the intersection, I need to have some sort of algebraic operation that's going to get something out of exponent land. I need an inverse of it, the same way that the inverse of multiply is divide, the inverse of subtract is add, the inverse of squared is square root. I always have an inverse operation. The inverse operation for exponents is logarithms. That's really spaced out. I'm going to do it as pretty colors instead. So if I have, how do I want to say? There we go. This is a biconditional statement. A biconditional statement is if and only if. You learned this back in geometry. If-then statement is a conditional. If and only if is a biconditional. It means goes both ways are true. A logarithmic definition says b to what power makes this thing. That's exactly how we run these. I'm asking right here, this is saying b to what power makes this definition, right? It's just a matter of putting the right things in the right spots. So if I say what is log base 2 of 32, I'm asking 2 to what power makes 32? 5. Okay. It is the inverse. How do we make inverses algebraically? Like if I got a function and I say make the inverse of this function, flip x and y, right? Inverses are swap domain and range. So without even looking at what's on your paper, if I swap x and y, I swap domain and range, a normal exponential function looks like this. So if I swap x and y, I can take this point, maybe it's at 3, 8. Now it's going to be at 8, 3. And I do that with all of my x's and y's, and I end up with this instead. Because I swap domain and range, that means I also swap the gaps in them. So if the domain of an exponential function is all real numbers, the range of a logarithmic function is all real numbers. If the domain of an exponential function is greater than 0, then the range is, then the domain of a logarithmic function is also greater than 0. Which means we got our third commandment of domain. Number 1, thou shalt not divide by 0. Number 2, thou shalt not take even root of negative numbers. And now, number 3, thou shalt not take log of any base of non-positive numbers. Meaning, the domain is always greater than 0. There's an asymptote at 0. Go ahead, on your calculator, try to find your log button. That's common log, base 10. We'll talk about it in a minute. And say log of 0, log of negative 2. And it says you can't do that. Okay? That is, log of non-positive is not possible. Meaning, there literally is no definition for it. If I try to apply a negative number to an exponent, it's not going to work in logarithmic form. Example, if I asked log base 2 of negative 8, you tell me 2 to what power makes negative 8? I'm going to repeatedly multiply together 2's and get a negative. Like, it is fundamentally impossible. No, not an imaginary number. Imaginary number is square root of a negative 1. There's a difference between imaginary and not possible. Imaginary is very specifically defined. Not possible is, no, you just can't do that. There's a difference between imaginary numbers and breaks math. Now these, yes, they broke math, but they broke math in such a way that we gave them their own little space.
So this one we're not going to like, it's not going to show back up.
So one day we're
It's
gonna
just
have to
not
break math. My children.
You got to go real far to start playing with this. A little past Calc 3 and DiffyQ. Okay. No. You got to go to some pretty funky math. You're getting into string theory before you start messing with this. To make up theories to possibly explain the way the universe exists. Because right now we don't have enough math, we don't have enough scientific knowledge to prove it. So they're all theories. Over here. If I got a definition of a log, now I can use the definition of a log to rewrite logs. This is asking 3 to what power makes 81? 4. That also works for rational exponents. 5 to what power makes square root of 5? Well, if I remember that 5 is to the first and this is a 2 as an index, then I'm asking log of 5 to the 1/2, like this. 5 to what power makes 5 to the 1/2? Well, 1/2. But if you don't know that, if you don't remember the rational exponents, then that might get a little bit funky. It also leads us towards properties. So let's see if you can kind of puzzle that out, especially 2b. 2b is a nice little logic puzzle.
I don't know.
What? The logarithm is the exponent of 3. Nice little logic puzzle. One. I wasn't sure if that was supposed to be 0. I thought you were like honoring Raya or something.
Okay. Because if this is the base, and if 3 to the what power reverse this.
You just put 2. I'm showing you why it's 2. Now, I want you to think about this. If that's not there, this is asking 3 to what power makes 1? 0, correct? So now I'm taking 3 to the 0 power. What am I going to get? 1. Now that works no matter what I'm using. If I took 3 to the log base 3 of pi, 3 to what power makes pi? It's an irrational number. But, okay, if 3 to equals pi, what happens when I take 3 to I will get pi. So whenever I see a logarithm and a base that are the same, they just cancel, and you get the object of the log. It's very logical. I know, I'm even disappointed at myself. So, you get some properties with that. The 2 that are shown here are for the common log and the natural log. Common log, base 10. Our entire number system that you have been working with since the dawn of your existence is base 10, because most humans have 10 fingers. If we had been born Simpsons, then we would have had 8 fingers. Then we would have been in base 8. Okay, here's what I mean. Yeah. So if I have, say for example, 5 plus 3. If I just count up 5 things plus 3 things, I get 8 things, right? Well, what happens if I instead say 5 plus 8? 13. Why do you all of a sudden have 2 numbers instead of 1? Because to me, that's D. Because I'm thinking in hexadecimal. Hexadecimal is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E. So E represents 15. When I hit 16, now I carry the place value. You know of this as 1, 2, 3, 4, 5 things, 1, 2, 3, 4, 5, 6, 7, 8 things. You have been taught that as soon as you hit 10 things, it goes to the next place value, because that's our base of our number system. I have a group of 10, therefore I will put it in the next place value. And then 3 left over, so 13. What I'm saying is, oh no, this is math. I used to do this with my SPED students to reinforce place value. If I say 5 plus 7 and I'm in base 8, when I hit 8, I'm in the next place value. So I count 0, 1, 2, 3, 4, 5, 6, 7, 10. Because I've hit 8 things. 8 things is a whole group. I go to the next place value.
That's 14.
8 and 9 do not exist. Since this is 12 whole units, but it's 4 past my grouping of 10.
Is there places that actually do that?
Uh-huh.
That makes me so confused. What?
There are elementary schools that now use games with place value in different bases to reinforce how we add and subtract.
This makes me confused. That would just confuse me.
So, no. So, what I'm saying is we use base 10 because that's what our number system is in. Because it is so common, we call it the common log. So if you ever see a logarithm that doesn't write the base, you assume it's 10. Just like if I ever see a radical with no index written, I assume it's a 2. So if I ever see log of a 5, I assume that there's a base 10. Because that's the number system that we work in. I'm saying our number system is based on 10 because of this. If we did not evolve to have 10 fingers, we would not be in base 10. I would be talking about what you think is 10 right now. I would have a completely different name for it. Because we would be in base 8. Base 8 is base 10. What are you talking about? Sorry, I just like theory of math geeked all over you. But so I'm asking 10 to what power makes 1? Well, anything to the 0 power is 1. So that also means log base anything of 1 is going to be 0. Because anything to the 0 power is 1. Notice what happens here if my base and the object of the log both match. I'm asking 10 to what power makes 10? Well, duh. So I could do that for anything. I could say log base pi of pi. Pi to what power makes pi? 1. Okay? So they're just doing it for common logs, but it's true for any log. In same thing here. I'm saying 10 to what power makes 10 to this power? All right. 10 to what power makes 10 to the x? Oh, x. If I said 10 to what power makes 10 to fart? Fart. Right? Like, it's anything. It is anything that you want to say. I could have log base 10 of 10 to the smiley face is smiley face. Because they will cancel. Just like they did on 2b, whenever the base and the object, or the base and the base of the log are the same, they will cancel. Because logic. Now, out of all of that, why does it say this at the end? This equals x, but only if x is greater than 0. Because thou shalt not take log of non-positives. Okay? Y'all remember E? We just talked about E. Same thing, but Because E happens so often, it got its own button on the calculator, right? Because log base E is going to happen so often, they gave it its own name. ln, natural log. Which bothers a lot of kids that it's ln and not nl. It's the natural log. Why is it ln? I have never taken French, but I think it sounds French. Log au naturel.
Adjectives come after the thing you described sometimes.
Oh, cool. I Frenched right.
I'll say I don't like it.
Oh, wait. Oh, yeah, don't say that. So anyway, all those properties are still the same when it's base E. What? Oh, did you do the daily quiz thing? The daily quiz thing?
Did you want me to look through and see what scores I got?
I'll score them.
You just told me to give you my notebook.
I'll score them.